Welcome back to Virtual Physical Science. We're going to start talking about the material in Chapter 10 of your textbook, different kinds of energy sources. And part 1 of that is to talk about fossil fuels. So, what are fossil fuels? Well, you're familiar with several of them, I think. Coal, oil, and natural gas are all fossil fuels. Those are the three main kinds. Gasoline, which is a kind of oil, or is a derivative from oil, is also considered a fossil fuel. So it's the fuels that are very common in our world today. They're called fossil fuels. The word fossil is used because these fossil fuels, are made from the decayed remains of ancient plants and animals that formed over a course of millions of years. Mostly microscopic things like plankton and algae, but also bigger things like plants that might be similar to plants that you would think of today. An important thing about fossil fuels is that they are non-renewable energy resources. That means that it takes millions of years to make more of them, and only a very short time to use them up. Another interesting fact is that fossil fuels account for by far the majority of the energy that we use on this earth today. Coal, oil, natural gas are more than 3/4 of the energy that is used by human beings. Now, there are some very important advantages to our use of fossil fuels. These fuels represent very concentrated sources of energy. There are chemical bonds between carbon atoms inside these fossil fuels that store a lot more energy than in other kinds of fuels. And so there's a good reason why we use them. They're very efficient, good sources of energy. Also, we have a lot of technology already designed to use these things. Cars, factories, and power plants that were made specifically to use fossil fuels as a source of energy. But unfortunately, there are also some significant disadvantages to the use of fossil fuels for energy. Probably the most obvious is that they are a non-renewable source of energy, which means sooner or later they're going to run out, and there isn't going to be any more. If you look at Figure 10 in Section 10.1 of your textbook, you'll see one prediction about exactly when that might happen. So I don't know exactly when it's going to happen. It depends on how efficient our future technologies are and how quickly we discover new sources of fossil fuels under the ground, but there is definitely a limited supply, and sooner or later we're going to have to look for different sources of energy. Another important disadvantage to their use of fossil fuels is that they cause and produce a lot of pollution. Anything from soot and ash particles in the air that can irritate your lungs, to sulfur and nitrogen oxides that can cause acid rain, to carbon dioxide, which causes, as we know, global warming. If you have a look at Figure 9 in Section 10.1, you'll see a graph illustrating how the amount of carbon dioxide in the atmosphere has increased throughout the last few decades. And a final disadvantage is a political one. Every time one country is looking for fossil fuels that happen to be under the territory of another country, there is bound to be some sort of dispute over who has the right to exploit and use those resources. Some people would say that this source of tension is what is behind a lot of the war and conflict and strife in the Middle East right now. There happens to be a lot of oil in the Middle East, and there's also a lot of conflict there. So this could be a coincidence, but whenever groups of people fight over the same resources, it's not going to be pretty. So how exactly are fossil fuels, things like oil and coal, used to make electricity? Well, there's a nice illustration in Figure 8 of Section 10.1. The basic idea is that you burn these fuels, just like a car burns gasoline, but in this case, in a power plant to generate electricity, the heat from burning this fuel is used to heat and boil water. When the water boils, it turns to steam, and the steam forces its way through some tubing and ends up turning a turbine. Now, a turbine is essentially a big fan with big blades on it, and the steam pushes on those blades and causes them to turn. This turbine is attached to what is a generator, and a generator produces electricity when you turn it. Now, we haven't learned how a generator works, and we'll probably learn about that in the next unit about electricity and magnetism. But if you can turn a generator, you can generate electricity. And that's exactly what we do by heating up this water. So, have a read through section 10.1 and see if you can answer the questions on page 297. Just work on questions 1 through 5. And I'll see you in part 2.